Chapter 2 is quadratics. Back in lesson 1.2, we did a little bit with quadratics, but now we're going to deal with the whole chapter that's quadratics. Some of this is going to be reviewed from Algebra 1. Some of it is going to be expanding on what you learned in Algebra 1. Now, as we look at lesson 2.1, I do feel like some of what we're doing today overlaps with what we did back in lesson 1.2. In lesson 1.2, I spent a day on absolute value functions, I spent a day on quadratic functions. So some of this is going to seem familiar. I've already taught it a little bit. Some of it we're going a little bit farther, though. And so, as we talk about quadratic functions, we are specifically going to be talking about the vertex form of a quadratic function today and what it can do for us. However, some basic information. A quadratic function is one that's of the form f of x equals ax squared plus bx plus c, where a cannot equal 0. Basically, if it's a quadratic function, what's the highest power you're going to see? You're going to see x to the second. That's what makes it a quadratic function, is if we have an x to the second term. Now, thus, all quadratic functions are transformations of the parent function x squared, y equals x squared. So everything we're working with is based on y equals x squared. What's the graph called? What's the graph look like? Is that u, yes? Yeah, the graph of a quadratic function is the u. The official name of that u shape is the parabola. Okay, so all the graphs we do in this chapter are going to be the u shape. Okay, every single one of them. Okay, vertex form of a quadratic function. This is our form today. F of x equals a times x minus h squared plus k. Where hk is the vertex. So it's called the vertex form because all I have to do is look at it and I know where my vertex of my parabola is. Okay, it gives me some very helpful information if I know where my vertex is. Now, back in lesson 1.2, I think I talked about the basic parabola here. Basic parabola, without any movement or anything, has a vertex at 0, 0. What are the other points that we talked about for this XY chart back in topic 1? Do you remember?
No.
Or look at your graph or plug some values in. 1, 1.
Oh, yeah.
Because 1 squared is 1. And notice, does it go through 1, 1 on the graph that I provided?
Yeah.
Yeah. What's the other value we talked about?
1, 2.
No. 2, 4.
Oh.
Because again, it's based on f of x equals x squared. And so 2, 4. Okay, this is all based on, and I should write it in here, y equals x squared. And remember, if you know the 0, 0, 1, 1, and 2, 4, that's the right side of the parabola. To get the left side of the parabola, you can reflect it over, flip it, mirror it, whatever vocabulary word you want to use there. Okay. If my vertex is 0, 0, do you remember where the axis of symmetry is?
X equals 0.
Yeah. Axis of symmetry is always x equals the x value. X equals 0. You have to put the x equals to get full credit. Some of you might have lost the point here or there on the test if you didn't put the x equals, right? Okay. Does this seem familiar? Just a little bit. Okay, because this is going to be what we're doing all chapter here. Now, I said we're working with quadratics all chapter. Before you stress out on me, we're not graphing all chapter. Okay? We're graphing parts. Like I know we graphed in lesson 1. I think we graphed in lesson 2. Graphing probably dwindles off after that. Okay, so you don't have to stress about, oh my gosh, this whole chapter. No, the whole chapter is not graphing. Now, Does this chart off to the right look familiar? It does. If you go back to your topic 1 notes, do you have this exact chart? Back in 1.2, absolute value, and 1.2 quadratic. Did we use it again? I don't know. We might have used it again. Maybe not. But I know I kind of made it small on your paper. You already have this chart. My point is that this chart still exists, right? We're still going to be using it. If you add or subtract a number at the end of the equation, it's going to make the graph do what? Go up or down. If the number is with the x, so in this case it's going to be if it's with the parentheses, and the number is added or subtracted, it's going to make the graph go left or right if we're adding or subtracting the parentheses. If there's a negative out front, we're going to reflect. If there's a multiplied value out front, we're going to stretch or compress. We won't talk about horizontal stretch or compress in this lesson. I just left them on the chart because I didn't want to change the chart. I want you guys to, have all the information. Now, before we go down and talk about quadratics and specifics here, I mentioned A a couple of places, right? A we know as vertical stretch or vertical compression. And that's what it does to a parabola, right? It can either stretch it up, make it taller and skinnier, or it can compress it down and make it shorter and wider. The A value out front. Okay, so the A value makes the graph either stretch or compress. Important things. If A is positive, what's my graph going to do? It's going to be a regular, everyday U-shape. Okay, if the A is positive, then regular, everyday U-shape, graph opens up. What if the A value is negative?
It goes down.
Okay, that's going to reflect it, yes. And it's going to reflect it across the x-axis. And so it's going to be an upside down U. Those are really key things to notice. If my A value is positive, right side up, U. If it's negative, upside down U. If A is a fraction between 0 and 1, then the graph is compressed. Don't we have that up there in our chart? Okay, if it's a number between 0 and 1, the graph is compressed. If the number is greater than 1, isn't that up here also? Then the graph is stretched. Okay, so my A value tells me all of that. But to me, key that I really need you guys to easily pick up on is right here. If that A value is positive, right side up U. If the A value is negative, upside down U. That's got to be locked in, guys. Okay. Ready to graph some of these?
Yes.
Or how about this? Ready or not? Here we go. You may not be ready, but we're going to go for it. Oops, too far. Okay, I have 2 examples here, and then 2 examples on the back side. But some basic graphing. When we graph, okay, today, lesson 2.1 is all about the transformations. So knowing how to graph with our transformations. So on these, we're going to describe the transformations, and then we're going to graph the function. I know this is an x squared function because I see my x squared, right? What do those other 2 numbers do to my graph? Go back to your chart up above. What's that -1 do to my graph? Right one?
Yeah.
If you go back and look at the chart up above, if it's -c in the parentheses, it's going to go right. So it's going to be opposite of the sign. So I'm going to write it out in words down below, but we are going to go write one. What's plus a number at the end of the graph do? Okay, the very top row right there. Plus C says we're going to go up C. So we're going to go, in that case then, up 2. Now, to get in the habit of writing with words, some of you write very well with words. Some of you want to make it as brief as possible. We don't want to get too brief, but what's the word? We said we're going to go write 1 up 2. What's the word I want to use here? Translate, right? Use good vocabulary. So I'm going to put it down here that we are going to translate the graph, write 1 unit, and what do we say? Up 2 units. Good vocabulary, guys. Translate, write 1 unit, and up 2 units. I didn't even go too fancy there. Could have gone a lot fancier. Do we reflect this graph? No. Out in front of my parentheses is no number. So that means it's going to be a typical right side up U, because my A value is positive there. Are we going to stretch or compress it? No. If you want to talk about this, there is an invisible number 1 there. And so we can talk about A as 1, but that just means it's a right side up parabola, no stretch, no compress. No compression, I should say. Okay, you ready to graph it? You guys know what to do here. What do I do first? We need to put our vertex on there, right? Normally the vertex is at 0, 0, but where are we going to take this vertex? Right 1 and up 2. So let's move that vertex, right 1, up 2. Now, we could put other values into our equation if we really wanted to and try and work that way. However, do you remember how I had you guys do this? What's a parabola look like? It's the U. It's that U at the top of your paper, right? Do we know some basic x, y values for a U? Do we have some basic x, y values here? Yeah. Once you translate, go back and use those. 0, 0 represents a vertex, right? From your vertex, we can go over 1, up 1, and over 2, up 4. That's my recommendation of what we do here. So from this vertex, I'm going to go over 1, up 1. I'm also going to go over 2 from the vertex, up 4. I only drew half a parabola currently. Where's the other half? On the other side, right? When you go right 1, up 1, you can also go left 1, up 1. When you go right 2, up 4, you can also go left 2, up 4. Remember, this is a U, not a V. Try and draw carefully. Try and not make it look V-like. Try and make it look U-like. And I'm just writing that XY chart there in case you need it, in case you look back and say, where'd you get all those points? 0, 0 represents a vertex. Go over 1, up 1, and over 2, up 4 from your vertex. Okay. That was kind of a review problem, if you ask me. We've done this, yes?
Yeah.
Not all of you liked it. So we're going to do it again, right? You're ready? Let's go to B. Let's add a step here. Notice, is this another quadratic? Well, there's probably one to say, yeah, it's another quadratic. That's what this lesson is all about. But what can we observe here? It's x squared, right?
Yeah.
That tells me when I see that x and that squared, it's going to be some type of parabola. What's being done to this parabola? It's not going to open up this time, is it? It's going to be an upside down parabola, isn't it? Because there is a negative here, because a is -1, that means my parabola is going to be upside down. I'm just kind of making notes to myself as opposed to right side up. What's the transformation called when my parabola goes upside down? What is this officially going to be? A reflection, yes. This is going to be a reflection across the x-axis when we write it out. Okay, what other pieces do you see? What's that +2 do? Okay, it's in the parentheses, so it's left to right, opposite the sign. So +2 is going to tell me to go left 2. Okay, did you write it in words? We said the negative is going to tell us to reflect across the x-axis, and my good mathematical word for the other part is to translate. Where are we translating? Left 2 units. Okay. Start with our vertex. Our vertex is normally at 0, 0. Where am I going to take my vertex this time?
Left 2.
I'm going to take it left 2. Instead of my vertex being at 0, 0, it's going to be at -2, 0. That's the only movement we had, right? What's the other part? We're going to reflect. So what's that going to look like when I reflect?
Go down.
Yeah. When I go to do my over 1, up 1, instead of going over 1 and up 1, we're going to go over 1, down 1. Instead of going over 2, up 4, I'm going to go over 2, down 4. Okay, so you're still using these same values here. It's just we're going to take them downwards instead. So right 1, down 1, and left 1, down 1. Right 2, down 4, and left 2, down 4. You know when you're on the right track at the end, if you get there, you're like, okay, yes, my parabola's upside down. I knew it would be upside down because there's a negative. That negative right there told me, okay, this graph is going to be upside down. That's a big thing to be able to recognize. Okay, questions there? Am I boring us? Too much review here? However, review, there was kind of some issues though. We didn't necessarily like this. Okay, let's go to the next two. More graphing still. I'm stepping them up a little bit each time. Tell me what you see. Is it still a parabola? Silly question maybe because of the chapter we're in, but I need you to be able to recognize them. Say you go and take SAT or PSAT or something, you know. You need to be able to recognize it's a parabola because we see x squared. What do you know about this parabola? There's a 2. What's that 2 going to do out front? Yeah, that 2 out there is going to be a stretch. And I'll write it out in full words down at the bottom. But it's a positive 2, so what do I still know about this parabola?
Facing up.
Okay, it's going to open up. Okay. What do this 1 and 3 do for me?
That's your vertex. You go right 1 down 3.
Okay, the -1. So inside the parentheses is left or right, opposite the sign. So right 1. -3 at the end is up or down, direction of the sign. So down 3. Okay. Use your words. Okay.
It's vertical stretch by scale factor 2. Translated right 1 down 3.
Okay. Vertical stretch by a factor of 2. Bless you. Translated right 1 and down 3 units. Okay. I'm always going to provide that chart for you. You know, the one we have on the green paper. I'm always going to provide that chart for you. But my hope is the longer we do this, the more you use that chart. Are you getting it memorized? Are you getting to the point where you don't always have to refer to it? Okay, so where's my vertex going to go? Vertex still moves. Right 1, down 3. Right 1, down 3. Now, how do we handle the rest of this? On a normal parabola, what was our chart we were using? We were using 0, 0, 1, 1, 2, 4 for our reference, right? So that was on a normal x squared. What do we really have here, though? We don't have a normal x squared. We have a 2x squared. So what you need to think, and that's because of this right here, how does that change my basic values? And there's a couple of different ways I can teach this, and I really debated how to teach this. I don't have a good answer. I can teach shortcuts. I can teach the actual thing, which is what I'm trying to do right now. If you think about the 0, 1, 2 chart, well, 0, 0 is always going to be 0, 0 representing the vertex. If you put in 1, 1 squared is 1 times 2 is 2. So instead of going over 1, up 1, you're going to go over 1, up 2. What about the 2? 2 squared is 4 times 2 is 8. So instead of just going over 2 up 4, we're going to go up 8. Basically, what did that 2 do? This 2 right here just doubled. When we had a stretch, a vertical stretch, it doubled our y values. Okay, it stretched them by a factor of 2, so it doubled the y values. If that connection helps. Now, in all honesty, to get the first point, instead of going over 1 up 1, you go over 1 up 2. It's the past that. So instead of over 1 up 1, over 1 up 2. Also means we can go left 1 up 2. Instead of over 2 up 4, we're going to go over 2 up 8. And left 2 up 8. Does this graph look stretched?
Yep.
Okay. Yes?
How'd you get 8?
8 came from, if we do the
Times 2.
2 times 2 squared. And the key is to remember that 2 squared has to be done first. So 2 times 4, which is 8. Does that help? I almost wrote that out earlier too, because. And on this one, it would have been 2 times 1 squared. That was weird. So 2 times 1. Okay. Okay, guys. Again, gets harder when they're stretched, but try and make it look U-like and not V-like. Now, as much as I'm practicing with these and whatnot, because we do need to know how to do these, I will say I was playing around in your Savas homework last night, and Savas actually has you enter the information, the transformations, into a little chart, and you don't actually graph it as much on your own. Like, you have to pick the parabola tool, and in this lesson, like, they ask you, okay, what's your horizontal translation? Well, what's our horizontal translation? We're going right 1, which is a +1. What's our vertical translation? Down 3, so that would be represented as a -3. What kind of stretch is this? This is a vertical stretch. So in the vertical stretch box, you'd enter a 2. Are we reflecting it across the x-axis? No. If so, you check a checkbox. So it's kind of interesting how they had you do it. And I kind of like that we need to know how to do these transformations as well. So, okay, one more. Can we get D in before the bell rings? I have positive thinking. I think we can. Wishful thinking, at least. Okay, guys, what about D? Is it a quadratic?
Yes.
Yeah, I see x squared. What transformations are being done?
Left to vertical compression by factor of -1 to
Okay, I got lost in his droning there, but okay, it is a compression. And what else? Okay. What's that negative? That negative says we're going to reflect. This parabola is going to be upside down, isn't it? Okay. So we've got to have all the pieces here. Now I'm going to put it in words, and that we're going to vertical compression. And why was this a compression? Because 1/2 is between 0 and 1, right? So vertical compression by factor of 1/2. Just use 1/2. Because what is the negative? The negative, it represents the reflection. So the stretch or compression is always a positive value. Because then the negative means I'm going to reflect across the x-axis. And what else were we doing? We're going to have a horizontal translation, left 2. Now, I will say, and maybe I should, I don't use the words horizontal and vertical on here very much, do I? Savas does. Okay, so, you know, kind of watch, because I could see Savas saying horizontal translation left 2 units or something. So, or horizontal shift, they might use the word shift. Okay, we ready? My vertex, instead of being at 0, 0, is going to be where? Left 2. Now, normally, what do we normally do on a parabola? We would normally go 0, 0, 1, 1, 2, 4, right? Is that what I'm doing this time? No. we have to think in terms of 1/2 x squared. We have to think in terms of 1/2 x squared. Now, a couple of things I can explain this as. Did you catch last time? Last time it was 2x squared, and what did my y values do? They multiplied by 2. This time it's 1/2 x squared. So what are my y values going to do? They're going to multiply by 1/2. Or, if you have an aversion to fractions, instead of multiplying by 1/2, that is the same as dividing by 2. I missed something over there. So, or if you put them in, 1/2 times 0 squared is 0. If I do 1 squared, half of 1 is 1/2. Ooh, I don't want to graph that one. Might have to find something else there. If I put in 2, well, half of 4 is 2. Or if you put in 2, 2 squared is 4. Half of 4 is 2. If we do another value, do you remember from chapter 1? 3 is going to give us another decimal, but 4 would give you something good if you wanted to throw a 4 in there, wouldn't it? 4 squared is 16. Half of 16 is 8. Okay. Now, before we go, you got to get this graph done with me. Normally we go over 1 up 1. Instead of over 1 up 1, okay, I'm going to skip 1. I'm going to do the 2, 2, 4, 8. So instead of over 1 up 1, I'm going to use 2, 2. Now, do I go over 2 up 2? No, because this is reflected. So we've got to go over 2, down 2. We can go over 2 both ways, down 2. And what's the other piece? 4, 8. So over 4, down 8. Over 4, down 8. If you use something like 1 over 1, down 1/2, you could do that. It's not that it doesn't work. It's just those half points are harder to make happen. Okay. We have a couple parts to talk about tomorrow. That was some heavy stuff there, so I knew it'd take us a bit to get through. Homework is out there. Honestly, you're not going to know how to do a whole lot of it yet. You would be okay with the graphing, but we'll talk about minimum and maximum values tomorrow. We will talk about how to write an equation of a parabola. Those will be the 2 big things we'll have to talk about tomorrow. Okay, so we'll finish those tomorrow. Homework will be due on Wednesday. Got it? Mm-hmm.